Hello, let's start with our seventh section. Now we're adding some monitoring capabilities so we can see what's going on without purely relying on logs. First, we have a look at the homegrown solution that many companies use in basically the same fashion. So we add a correlation ID, which can be used to trace calls and events over multiple systems. Then we add the Hystrix dashboard and Turbine as aggregation mechanism, which provides us a lot of visibility for the code, which is protected by Hystrix commands. Then we introduce Spring Cloud Sleuth, which is a wrapper around call and message tracing systems like Zipkin, which has been created by Twitter. After that, we add something that has been created by the community and is now added to the Spring Initializer, the Spring Boot admin frontend. This helps to get some insight into your running services and also offers a few ways to override environment properties, log levels, etc. And as last topic for this section, I will provide some insights into monitoring of such services from the real life. Hello, now we're going to add some homegrown call tracking. All calls first hit the reverse proxy, so we can generate the ID here, which also means we need to pass it down to the backend systems. Then we enhance the bookmark service to receive the ID and use it for logging, and pass the ID along when we call the rating service. As last part of this call chain, we need to enhance the rating service as well, but here we just need to receive the ID and use it for the logs. So let's start with our do-it-yourself tracing. First of all, we are going to just add a tracing ID, which we can follow in the logs. So for this, we need to log it. And so we don't have to do that for every service. We're using the config server to spread this configuration to every service. So we're going to use something for the pattern level. So here we can configure how the log level is shown. We don't have to provide the full pattern here, which is nice. We're just fiddling a little bit around inside of the pattern. So we say the CID for correlation ID should be something like X curly braces, and now I can access the MDC, which is a diagnostic area in the loggers like logback and log4j, and now I can access a variable here. So let's say correlation ID, and when there is none, then don't print anything, and we still should provide the pattern here. So %5p means for 5 characters put in the pattern level here. Alright, so after we did that, we can start the config server again. As you can see, the service registry user application, we can shut down this as well. The ratings application needs to be restarted soon anyway. So let's get rid of this. So first we are going to secure or to configure our entry point, which is the reverse proxy. We want to enhance every request by the logging ID. You have seen the Zool login filter already, and we are creating another one. So let's create a new class, or we can just copy that one. It's much easier. Let's call it correlation ID Zool filter, for example. So this is not post type, this is pre-type, because we want to execute it before the request has taken place. Filter order 0 is okay. Should filter is always true, because we want to do that for every request. And now we have to provide the ID. So string ID equals UUID dot random UUID dot toString. So this generates a unique string for us, which is all we need. So, and now we access the request context and get the current context. And now we just add Zool request headers, which means that this is the request that Zool passes to our internal service. So, and here we use, I don't know if we have the correlation ID, import static constant. There is already a very nice constant for it in the integration message header class, and value is just correlation ID in camel case, which is what I would have used anyway. So, and as we have seen in the log config in the config server. So, and here we have to provide the ID. Just in case this request leads to some log output, we can also set the MDC value here, which is also correlation ID and ID. So MDC is static class, as you can see, with a static getters and setters, and it's making sure that for the current request in the current thread, you know the drill already, we can access these values in our log statements. All right, that's what we have to do for the reverse proxy. So let's start that one as well. And next is the bookmark service. Come on, open it. So let's create a new package. Let's call it tracing. Oh, I have an empty package already, so you might have to create it. So, and in here, first we are going to create a filter for regular requests. Let's call it correlation ID filter. This will be a component, and it needs to have a special order because we want to have it ordered dot highest precedence. So AtOrder enables us to provide an order for components because this will be a request filter. There is an interface for that, but there's also a few helper classes, for example, a once per request filter base class, which makes sure that no matter what we do, this is only called once per request, which is sufficient. And due to the high precedence, we are sure that this is executed before any other service. So we should be pretty safe that any log statement that will be generated will have access to our request ID. All right, so we want to get the correlation ID. And for this, we can access the header. But what if the header doesn't contain such a request? In this case, we should provide our own version. I'm only doing this here, so let's do of nullable. So we're using optionals again. And then we say request.getHeader correlation ID. Import it again. We have to make sure that we use this one because that one has AMQP underscore in front of it, which is not what we want. So, and or else uuid.randomuid.toString. Actually, that's not perfect. It would be better to provide a lambda here so we don't create random UUIDs just for fun. Let's multi-type it. I won't do it now. So, and now we just say mdc.put correlation ID. And just for fun, now I want to have this left4j log.info got request and then request.getHeader correlation ID. All right. And now we have to make sure that the request is really handled. So we have to do filter chain dot do filter request response, and we're done. Why am I doing this? Using LockInfo, we will create a log file which will contain the correlation ID that we have defined here. And we are logging the correlation ID from the request header so we can see that we are really using this correlation ID and not the one that we have created here. So, not a lot of time left, but we can start. So let's create a new class, because now in case we are using Hystrix, we have deactivated Hystrix right now because we are using events. But if we wouldn't, it would be a good idea to make sure that MDC is available inside of our Hystrix commands, which we can do by creating a correlation ID Hystrix concurrency strategy. I will explain this in a bit. ID Hystrix concurrency strategy. So we're in Java, so we use long names. All right. So this will be a component, and it will extend Hystrix concurrency strategy. So I'm creating the Hystrix concurrency strategy. This is something where Hystrix allows to have you one concurrency strategy, and it is set using static setter, which is pretty bad. But Bring created for us a Hystrix concurrency strategy that is registered, and it will pick up any component that extends this class, which means that we now can have multiple concurrency strategies just using Bring, which is very nice. We can just use this and we don't have to do anything more. So, but of course we have to do something in here. Let's override a method, and it is the wrap callable. So let's get rid of this. So this will be called when Hystrix is going to execute something in its own thread. So this code here is executed in the outside thread, like the thread that processes the request. So what we can do here is we say mdc.get copy of context map and assign that to a variable. And in here we can now provide a lambda which implements this callable stuff here, and here we can do something like try mdc.setContextMap, and now we use the map from outside, and then we say return callable.small callable. And then finally we also clean up the MDC just to be nice, so we don't have any residual stuff in our MDC in case of reuse. Alright, so this is outside of the thread, and this will be called later inside of the other thread, so we can copy all that stuff over and we can just create log statements inside of our Hystrix commands now. So, but we have more. We also have messaging. So when we also want to pass the correlation ID to using our messages to another system, then we have to do a little bit more. For example, we create correlation ID channel interceptor, channel interceptor, and this class also be a component. So it's picked up by Spring, gets the global channel interceptor annotation, which means that this class is applied to any channel and not to a specific channel. And now here we can provide a few things like a pattern to a group of channels, for example, or we can provide an order. And here we use ordered.highest precedence again, so we make sure that this is called first. And this class implements an interface called channel interceptor. This is a Java 8 interface, so we don't have to provide anything because there are default implementations provided everywhere, which basically do nothing. Of course, we want to do something, so let's override the pre-send method here. Rid of this. You can have a look at it yourself. So this will be called before we send a message out, and when we receive a message, it will also be called before we get the message to process, which is a little bit weird in my opinion, but well, it's that way. So we have to make sure here. So we say if message dot get headers dot contains key correlation ID. Let's import it. This is the case when we receive a message, because we don't provide that key, so it's a nice indicator what we have to do. So when we receive something, of course, we should put the correlation ID into our MDC. message.getHeaders.get correlation ID. And this is an object, so we have to cast it to string. All right. So, but what if we are in the other case? This means that we are sending a message. The getHeaders is immutable in this case, which is not that nice. So what we have to do is we have to replace the whole message. So we use the message builder again, that we have seen before. We say with payload, message.payload, so we just copy this over. We have to copy all the headers from the original message. And we have to set a new header, which is now possible because we are in the builder. So correlation ID with the, where are we? mdc dot get correlation ID dot build. So what are we doing here? When we receive a message, we use the message correlation ID to put it in our log context. And if we send a message, we have to make sure that we put the correlation from our log context to the message, so the other side receives the same message ID. So what we can do here as well is we just log some so we can see that it works. Pre-send message, and then we just say message.getHeaders.get correlation ID. So no matter what happens, we can print this out. All right, so this is what we have to do here. Let's quickly start this up. And now we can copy this whole package to the rating service. So as you can see, it would make sense if you create something like this to put it in a separate library, for example. But here we don't have hystrix. As you can see, it's complaining. So let's just get rid of this. We only need these two here. So, and now we can also start the ratings application. So as you can see, here is already the CID, and here as well. Of course, here we don't have a CID because these are system messages. So it doesn't make any sense to do that. So we don't. Let's go here, reload, admin, password, and login. So let's add a bookmark. As you can see, the rating service is not registered here, but we don't care. We just delete it again. So as you can see, here are some requests. So here got request. This is ends with 61F. And here also have 61F. So this means that the CID we received is the same as we're logging, which is nice. And also here in the ratings application, you can see that we have a few calls with the CID. And here you can see pre-send message with ending with F4, which is also the same as here. And you can see receive delete event. So what we can do now is we use this one and just, for example, search here. And as you can see, now we can have a look what log messages have been produced, which later led to the delete event. So now we have cross-service call tracking. Of course, doing this by hand is not a very nice way to work with all that stuff. But when you have your real application running, which we will see later, hopefully in the Docker sections, then you can have a log aggregator, which fetches all logs from all services. And then you can just search across multiple logs using one search phrase. And then you can see like a story what happens during a request, which is quite nice and sufficient for many cases, but it's still not perfect, which we're going to address in the next videos when we switch from our homebrew solution to something that is already used in the industry out there by big companies like Twitter. All right, see you in the next video.